We have Nima, the head of AI at EigenLayer, talking about multi-chain interactions of AI agents.
Okay, so we're here to talk about verifiable agents in a multi-chain world now. Yeah, already got introduced, so let's just get into it. Now, what is the agenda? Everyone's talking about AI agents, etc., but people also are thinking about why they need verifiability. So we're going to go into that. We're going to go into EigenLayer secrets and how, as a protocol, we fit into the open innovation model, and as well, we're going to talk about how scaling agent interop works via Polymer. So why verifiability for agents? Well, let's revisit why everyone's talking about AI to begin with. So what is happening? Like, the entire fabric of society is being rewritten. But what does that mean exactly? Two specific problems that are occurring. There's this saying in crypto that everyone knows about, which is not your coins, not your keys, not your coins. But then it was amended by Andrej Karpathy, co-founder of OpenAI, which is not your weights, not your model, not your brain. And he's referring to this concept of, if you don't know what model is actually running where and who and why, you don't actually have the capability to understand what biases are at play and how the intelligence capabilities that you're being introduced to via these products, whether it's ChatGPT or otherwise, how those can be changed, or what you're exposed to, basically. So the problem exactly here is, as models become smarter and our reliance increasingly ends up being on their intelligence and reasoning and domain knowledge and so on, the question becomes, who deploys these models and what are they exactly deploying, right? We're seeing products like Deep Research come out and talk about the capability of giving you the access to do very thorough diligence on pretty sensitive issues like financial stuff, law, so on and so forth. But we don't have any clarity in terms of what biases and guardrails go into these products. The other way of talking about this is permissioning these products, right? And how that ends up manifesting in terms of like what transparency means here. So the second question we're going to visit is scalable content creation. Now, some protocols are working on this, but the questions that we run into for what you're seeing on TikTok, content gets remixed, music, etc., Midjourney. How do we counter the slop that we're seeing on Twitter? What's fake, what's real? Deepfakes are a really big problem. Who owns what, and who gets compensated for what? Now, before we get to those exactly, does decentralizing AI actually solve these problems? And if so, how? But the better question would be, why do we need decentralization to begin with, right? What is the exact outcome that we actually want? So what we actually want is enforceable commitments, and I'll get into why that is. The problem statement number one ends up being who commits to what model. It's a commitment that we actually care about. Now, diving into that specifically means what happens when whoever deployed the model changes their idea of what that commitment actually means. And problem number two, it becomes who owns what content and how are they compensated for it. So what happens when the idea of commitment around the ownership and around that compensation changes? Now, the goal is then making commitments accessible. Now, we're pretty familiar with the idea of commitments. It's just they're not super well grokked by society at large yet, but we do have a couple examples. So Bitcoin made this concept of 21 billion Bitcoins as a commitment. Ethereum did a similar thing with apps like Uniswap and etc. But they're still not super accessible in the sense that if blockchains can give us commitments, why can't we just throw AI on it? And that's because it's too expensive still. So if you look at what agents actually are, right, this is a rough picture of how agents are comprised, right? So you have some runtime, you have some tools that the agent uses to make some kind of actions and stuff. You have the orchestration, which kind of glues everything together, and you have the model or the LLM that's like does the reasoning for it. So this is more or less how many agent frameworks actually work. Now, when we say agents become verifiable, or you want to throw them on chain, what that means is you make every single part here verifiable. So the runtime becomes verifiable. Is it a TEE? Is it something else? You make the model verifiable, like, whether it's a Llama model or something else, or DeepSeek, and you make the tools verifiable. The call that I actually make, are the results of that coming from the service that I actually think they're coming from? So again, verifiability abounds. Now, when we project all these components on chain, this is roughly what we're looking at, right? If you assume everything is a smart contract, you have these tools being smart contracts, you have the orchestrator being a smart contract, you have the LLM being a smart contract. But again, the two things that we care about here primarily are inference costs and memory costs, which become way too cost prohibitive and too expensive. So the question then becomes, how do we create commitments around AI? Now, this is where EigenLayer steps in. To zoom out a little bit, what we care about at EigenLayer is, one of our secrets is crypto is the greatest upgrade to the civilization since the US Constitution, which is effectively some kind of a commitment. Now, decentralized trust is the only net new thing that we have made with crypto. Depending on how you phrase it, decentralized trust is the same thing as a commitment. Decentralized trust is a mechanism to give you a commitment. And EigenLayer will be the universal layer for decentralized trust. In terms of how we go about doing that, we have this notion that society runs on two different layers. One is the innovation layer, one is the coordination layer. For innovation, it's things like free market. You have services, goods, ideas that get tradable in the open markets. And then for coordination, again, we have the Constitution, which hasn't really seen a lot of progress for a while. In terms of the innovation layer, technology has accelerated the free market quite substantially. And a specific example of that that's rippling throughout society is AI. For coordination, that hasn't really seen that much progress. We have things like gold, money, common stock, double entry accounting, things like that. So for open innovation, we have 4 layers so far. How do we improve on coordination? Bitcoin gave us this vertically integrated stack that its application was one thing and one thing specifically, which was store of value and potentially trading, and if that's what you care for. Now Ethereum came along and evolved that and said, hey, we can use the bottom of the stack, the execution capabilities, but you can do more than one app. You can do multiple apps. A step beyond that is we have rollups, right? Either generic or app-specific rollups that gave you the ability to modify execution environments and give life to even more apps. Now, with EigenLayer, you have a very similar kind of evolution, but in this case, the consensus layer, basically what you're, the commitment schemes that you're actually using to verify how those execution layers operate ends up becoming the thing that gets unbundled a little bit. Now, that takes the shape of AVSs being the primitives that are built on top of this shared security layer, which verifies the commitments. And AVSs by construction are very much chain agnostic or rollup agnostic, similar to a lot of the stuff that Polymer has been thinking about. How do we live in a multi-chain world, chain agnostic world? If you have multiple rollups that do different things and effectively act as app servers, then AVSs exist to augment the functionality of those app servers. Another way to think about this is if you have an app server specifically dedicated to logic X or Y, you might want to augment the functionality of that smart contract in specific ways that are not well attuned to the construction of that chain. So you end up using core processors or oracles or whatever else that can be implemented as AVSs. When we get to the AI specific side of things, these are all the set of things, or all the set of AVSs that inherently support the entirety of the AI stack. We're seeing things from data collection and data attribution and generation, which are very important for actually developing a model, all the way to training, fine-tuning, as well as how models are deployed. You have TE networks, AI customized sidechains, which embed certain operations, like stateful precompiles, verifiable inference, and then you have tool calls, which is what we're going to get into in a little bit. And I think the part that we're going to focus on is the historical chain state reads. Now, going one step forward, now we have Polymer at glance. The previous presentation that we went through kind of unpacked what is actually happening here, right? But I think the important takeaway is the Prove API. Any chain that you're looking at, right, that you want to consume its state, you can effectively request the proofs, use the Prove API, get that proof, either self-verify it or post it somewhere else, And this effectively becomes one of these tool calls that an agent can make. So regardless of where an agent lives, it can make the query, get some proof of some state, of some chain, doesn't matter. It can self-verify it, and it can plan and execute a bunch of more complex actions that it can do so verifiably off-chain, so it doesn't incur the cost of on-chain compute. And then it can settle on-chain whenever it wants to. So that's sort of like what the future version of the world is going towards. Chain agnostically, you can request state proofs, you can self-verify them, you can do a bunch of other stuff, whether it's like planning trips or whatever, and you can settle on-chain in terms of if you have asset updates or whatever the agent needs to do. That can happen ultimately at the very end. So that is pretty much it. I know I went through that really fast, so we can leave time for questions.